Probability examples, example 25, G through M. All right, G says 5 cards are dealt from a standard deck. What is the probability of being dealt 5 black face cards? Well, for our denominator, we're looking at all the ways that you can choose 5 cards from a 52 card standard deck. Remember, order does not matter, so 52, C5, that's all the ways that that could happen. But we are looking for the probability of being dealt 5 black face cards. So how many cards are black cards and they're also face cards? Well, we've got Jack, Queen, King of spades, and we have Jack, Queen, King of clubs, okay, for a total of 6, and we want exactly, we want exactly 5 of those. So I will end up with 6 over 2,598,960. H, in the multi-state Powerball lottery, 69 white balls, numbered 1 through 69, are placed in a machine and 5 are drawn at random. Order is unimportant. So right now it looks like we're looking for a combination. Then 26 red balls, numbered 1 through 26, are placed in a machine and 1 is drawn at random. You and your co-workers purchase 20 tickets, each with a different set of numbers, in hopes to win this week's $500 million jackpot and split the proceeds. What is the probability you and your co-workers win? Okay, so you guys are going to be purchasing 20 different tickets. Okay, so let's look at the probability surrounding the 5, let's see, what color were they? White balls. Okay, so how many ways could you choose 5 from 69? Where order doesn't matter, it'd be 69C5. And we want to win, right? That's what we're looking for the probability of. Well, there's only 5 winners, and we need to choose all 5 of them. All right, then there are 26 red balls, and only one of them is a winner. Now, I've seen people put 26C1. Well, that's going to give you 26. There's only one winning ball, so I've seen people put 1C1, but isn't that just going to be 1? All right, so when we multiply across, we get 20 over 292,201,338. I, a group of friends meets for appetizers at a restaurant. The menu offers 12 different appetizers, 5 of which have cheese as an ingredient. It will be a good idea to make note that if we have 12 total appetizers and 5 of them have cheese, it means 7 will be without cheese. Okay, if the friends order 6 different appetizers, what is the probability that exactly 2 of them will have cheese? So we're ordering 6. We're ordering 6 total. 2 of them, 2 of them will have cheese. And that means that 4 of them will be without cheese. Okay, so the probability then of ordering 2 cheese appetizers and 4 not cheese appetizers. Well, let's look at the denominator. There are 12 appetizers. Does it really matter at what order you order those appetizers? No, it doesn't. So of those 12, we're going to do a combination of 6. So that's all the different ways that it can happen. Well, we have a specific order here. we want 2 with cheese, and so we have 5 that have cheese and we need 2. And that means we want 4 without cheese. So how many do we have without cheese? 7. And we need 4. So that will give us 350 in the numerator. And in the denominator, that gives us 924. And then when we reduce that, we get 25 over 66. J, a group of friends meets for appetizers at a restaurant. Starting to sound like the same. The menu offers 12 appetizers. We already know about that. 5 of which have cheese as an ingredient. Sounding hauntingly familiar. So we have 7 without cheese. If the friends order 6 different appetizers, that's still the same here. We want 6 app total. What's the probability that 2 or 3 of them will have cheese? Well, it looks like we have, we've already figured out the probability of 2 having cheese, haven't we? So what are we looking for? We are looking for 2 with cheese and 4 that without the cheese. Okay, or 3 with cheese, and then that means 3 are gonna not have cheese. Sorry about the stumbling there. All right, so remember that or means add. We know we'll have to do some addition there. So the denominator, let's look for all the different ways that can happen. And so we already know if we want 2 cheese, we have 5 that have cheese, we're taking 2 of those. So 7 don't have the cheese, we need 4. Or, so this time we're going to do 5C3 and 7C3. So when I multiply across in the numerator, I will get 700. The denominator, I get 924. And let's see if that reduces simply for us. In this case, we get 25 over 33. All right, K is going to throw a little bit of curveball for us. In fact, the last 3 are going to be a little bit different than the ones that we have done so far. So it's going to be a bit of a review. A bowl of candy contains 13 Reese's peanut butter cups and 9 Kit Kats. If you pick 2 at random, what is the probability the second is peanut butter cup if the first was a Kit Kat? So this looks like conditional probability. So we want the probability that the second one was peanut butter cup given the first was a Kit Kat. So we're assuming the Kit Kat's already been taken. So look, initially we have a total of 22, but someone took the Kit Kat. So now we only have 21 because we just have 8 Kit Kats. Okay, so then what's the probability of getting the peanut butter cup? It's going to be 13 out of 21. L, there are 5 red, 7 blue, and 4 yellow marbles in a jar. If 3 marbles are chosen without replacement, what's the probability that the marbles are drawn in this order? So we have a specific blue, and then red, and then another blue. So remember, and means multiply. So we have a total of, it looks like 16 marbles. So we have 7, the probability of choosing that first blue is 7 out of 16. All right, so we have a blue gone. Now we have 6 of them. And we don't have 16 marbles anymore, do we? We have 15. So then the probability of the red marble being drawn, given that the blue was already drawn, is 5 out of 15. Okay, and then, so we only have 4 of those reds. And it also means we only have 14 marbles left. Okay, and then another blue. Well, we have 6 blue marbles now. So let's multiply across. So that gives me 210 over 3,360, and that reduces to 1/16. Lastly, when playing the game of the same name, a Yahtzee is when you obtain the same number on all 5 dice. What is the probability you roll a Yahtzee on the single roll of a dice? So I know this is going to seem a little bit cumbersome, but I think it will help you understand what we're going for here. We're really looking for the probability of all 1s, or all 2s, or all 3s, or all 4s, or all 5s, or all 6s. Okay? So let's think about just even the probability of rolling all 1s. Okay? So you need a 1 and a 1 and a 1 and a 1. I've lost track 5 times. Okay? So you have 1 6 times 1 6 times 1 6 times 1 6 times 1 6. So that's the probability of all 1s, right? Now remember, we could rewrite that as 1 6 to the 5th power. Let's do that instead. Now you need this 6 times, okay? So remember, repeated addition is multiplication. So instead of doing this 1 6 to the 5th power plus 1 6 to the 5th power and so on, I could just multiply by 6. Okay, so that's going to give me 1 6 to the 5th power is going to be 1 over 7,776 by multiplying that by 6. So 6 can go in the numerator. Let's see what this reduces to. We would get 1 over 1,296.